This is Lesson 16:2, Changes in Scientific Thinking and Practice. What intellectual and social changes occurred as a result of the Scientific Revolution? And once again, we've got that College Board topic, 4.2, Scientific Revolution, the rediscovery of works from ancient Greece and Rome, and observation of the natural world changed many Europeans' view of their world. And it says, explain how understanding of the natural world developed and changed during the Scientific Revolution and the Enlightenment. We've seen that, but now this is something new. Francis Bacon and René Descartes defined inductive and deductive reasoning and promoted experimentation and the use of mathematics, which would ultimately shape the scientific method. And anatomical and medical discoveries by physicians, including William Harvey, presented the body as an integrated system, challenging the traditional humoral theory of the body and of disease espoused by Galen. And we're still in the same places: England, France, Dutch Republic, Italy. Key players of the Enlightenment, we've got a few different people now. We've got Francis Bacon on the left. We've got René Descartes on the right. We also have Robert Boyle, Andreas Vesalius, and William Harvey. Key concepts of the Scientific Revolution: empiricism, Boyle's law, experimentation, this idea called first principles, and Cartesian dualism. Three important aspects of the Scientific Revolution that you got to keep in mind. Number one, advancements occurred in many fields, not just astronomy. And number two, scientists collaborated with a class of skilled craftsmen. And these skilled craftsmen invented new instruments for the scientists, and they assisted with experiments. And number three, women were largely excluded from this intellectual community, although we've got a lesson, 16.6, on women in science. Scientific methods. Experimentation is the key, and we begin with Francis Bacon, who lived from 1561 to 1626. He was English, and Bacon advocated improved methods for experimentation. And he developed the idea of empiricism, also known as inductive reasoning. So empiricism and inductive reasoning are the same thing. And in empiricism, you collect data through observation and experimentation, not by reasoning and speculation. So you do not speculate about anything. It's all about what you can see and measure. And this method was widely accepted throughout England as experimental philosophy. Well, then you've got this other person. Scientific methods, experimentation is the key, or is it? René Descartes, 1596 to 1650, French guy, soldier in the 30 Years' War, advocated perhaps what you might call the opposite of empiricism. Descartes was another math guy. Math whiz, right? He gave us analytic geometry. He discovered a perfect correspondence between geometry and algebra. He showed how geometric figures can be expressed as algebraic equations and how the inverse algebraic equations can be expressed as geometric figures. René Descartes gave us the discipline of mechanics. Mechanics studies the nature of matter. Mechanics is a branch of physics that deals with energy and forces and their effects on objects. And Descartes said that the universe is mechanistic by nature. It's a machine. It's mechanical. Its processes happen the exact same way each and every time. And therefore, the universe is capable of complete explanation by the laws of physics and chemistry. Galileo had previously proposed that all matter was basically the same. Indeed, any element on the periodic table is composed of protons, neutrons, and electrons, as you know. The Greeks had suggested that matter was composed of tiny particles called atoms. But the question is, how do these atoms interact with each other? For example, how do they bond with each other? Descartes suggested this, that matter is made up of identical particles. These particles collide with each other endlessly and are constantly moving. and every natural occurrence can be analyzed as matter in motion. The amount of motion in the universe is constant. There are no vacuums. In other words, there are no empty spaces between particles in motion, and therefore there's no reaction among particles happens in isolation. And so therefore the universe is simply one big chain reaction. René Descartes gave us deductive reasoning. Easy way to remember that, right? Descartes, deductive reasoning, right? Deductive, Descartes. So while the inductive reasoning of Francis Bacon said only trust what you can observe and experiment with, deductive reasoning says doubt the senses. So that's the exact opposite. Aristotle's model of the universe with its crystal spheres made up of quintessence had been popular precisely because it had appealed to the senses. It looked like it made sense. So therefore, you have to be willing to systematically doubt your senses because they can deceive you. Doubt everything that can be doubted. Doubt until all you have left is so self-evident, so obviously and blatantly true that it cannot be doubted any further. And when you have arrived there, then you have arrived at what Descartes called a first principle. Therefore, a first principle is an assertion that has been purified and refined to the extent that it contains absolutely no possibility of doubt. And now that you've refined it that far, now you can put that first principle to use scientifically. You've already established that a first principle cannot be doubted, and therefore you must be completely safe in using that first principle as an axiom or a foundation for deducing an entire body of knowledge just with your mind. And that is what is called deductive reasoning. The most famous first principle that Descartes ever came up with was, you're familiar with it, I think, therefore I am. In other words, I'm thinking right now. That can't be doubted. So therefore, that's a first principle. And therefore, I have a mind, therefore I have existence. See, so you're kind of deducing the fact that you exist from this principle that can't be doubted, that you are thinking. René Descartes also gave us Cartesian dualism. And Cartesian dualism says that all of reality is really just two substances, mind and matter. Descartes was widely accepted in France and the Netherlands, but not so much in England. So now you have these two opposite end approaches to science. Both of them push the scientific method forward, but both have limitations and insufficiencies on their own. For example, Bacon's inductive reasoning, his empiricism, it fails to appreciate math. And as for Descartes' deductive reasoning, well, can you really deduce all of medicine from first principles? I don't think so. Medicine, the body, and chemistry. Experimentation really wins the day between these two conflicting philosophies when you study these 5 pioneers of medicine, the body, and chemistry. And one thing that makes medicine, the body, and chemistry different from astronomy is that it's much easier to do hands-on experiments, right? It's hard to go out to the stars that are light years away and do experiments on those stars. Although Galileo, with his balls on the wooden floor, he did prove that it wasn't actually impossible, right? And so here's a quote from William Harvey. I learn anatomy not from books, but from dissections, not from the tenets of philosophers, but from the fabric of nature. Empiricism, right? Experimentation. Hands-on. Well, let's go way, way back and start with a highly influential person, Galen of Pergamon. He was Greek. He lived from 130 to 210. He was a physician. So Galen obviously lived more than 1,300 years before the Scientific Revolution. So why is he here? Why is he mentioned by name in our College Board course description? Well, Galen established the traditional theory of the human body that lasted all the way up until the Scientific Revolution. Galen was a kind of like an Aristotle of human physiology. And Galen said that the body contained four what he called humors, liquids: blood, phlegm, black bile, and yellow bile. And illness resulted from an imbalance among these four humors. And that's why bloodletting was frequently prescribed to rebalance the humors. In other words, well, you got too much of one of these liquids in your body. It's probably the blood. Let's let some of that out, so we'll rebalance, these four humors. Then you've got Theophrastus Paracelsus, Swiss guy, 1493 to 1541, physician. And Paracelsus was also a bit early for the scientific revolution. He was an early proponent of experimental methods, and he said that illness was due to imbalances, but not imbalances in the four humors. Instead, these imbalances were chemical in nature. And Paracelsus advocated the use of chemicals and drugs to address illnesses. And then you've got Andreas Vesalius, Flemish, 1516 to 1564, physician. And Vesalius dissected human bodies. And in 1543, he published On the Structure of the Human Body. And this was the same year that Copernicus published his book on heliocentrism, on the revelation of the heavenly spheres. Vesalius' book had 200 drawings in it, and with this book, Vesalius revolutionized human anatomy, and he shot Galen's old four humors theory down completely. Then we have William Harvey, English, 1578 to 1657, physician, and he was another proponent of experimentation. And in 1628, he discovered circulation of the blood through veins and arteries, and he explained what the heart did and how it worked. Robert Boyle, English person, 1627 to 1691, physician, perfect hair, as you can see. And once again, another huge advocate of experimentation. Robert Boyle developed modern chemistry, and he helped found the Royal Society in 1660. Boyle used experimentation to discover elements, and he created a vacuum. Creating a vacuum disproved Descartes, who said that there were no vacuums. So now Descartes' deductive reasoning is really losing out to Francis Bacon and empiricism. And finally, Boyle discovered Boyle's law, which said that the pressure of a gas varies inversely with the amount of volume that it occupies. Makes sense. Science and religion. All of these scientists that we've talked about were deeply religious. And that's a big difference between the scientific revolution and the Enlightenment, which we will study next. These scientists saw their work as God ordained. Their attitude was, God gave me this mind and God gave me this curiosity. He must want me to reveal his glory. Heliocentrism presented a logical problem for many people. Why would God create this universe and not put man, his most amazing creation, made in his own image, dead center? All the major religions had problems with heliocentrism, not just the church. The Catholic Church was slow to respond to the heliocentric theory. Remember that Nicholas Copernicus and Tycho Brahe couldn't match their observations to their theory without the three laws of planetary motion. Johannes Kepler resolved those problems by formulating those three laws of planetary motion, but he couldn't produce the mechanics to explain why objects move in the first place. Nevertheless, the Holy Office took some action in 1616, calling heliocentrism foolish, absurd, and formerly heretical. Now remember that the Holy Office is also known as the Supreme Sacred Congregation of the Roman and Universal Inquisition. The Holy Office put all works advocating heliocentrism on their index of prohibited books, which we studied when we talked about the Age of Reformation. Pope Urban VIII became pope in the year 1623. He was against heliocentrism, but he was generally pro-science, and he and Galileo were friends, and Urban VIII and the Jesuits supported Galileo at first. They liked Galileo's teaching about experimentation and mathematical formulations. In 1632, Galileo made a big mistake. He published a third book called Dialogue Concerning the Two Chief World Systems. And in this book, Galileo seemed to ridicule geocentrism, the idea that the earth is the center of the universe, which the Pope and the Church supported. In the book, the Pope's point of view was argued by a character named Simplicio, and I'm sure you can understand where that's going. And Galileo alienated his best supporters in the Church, the Pope and the Jesuits. In 1633, Galileo was tried by the Roman Inquisition, and the verdict was vehemently suspect of heresy. That was the verdict. He was threatened with torture. He was forced to renounce and curse his Copernican errors. He was placed under house arrest for the rest of his life. That was 9 years. He was almost 80 when he was tried. And the Catholic Church became more hostile toward heliocentrism after that. Science in the Protestant countries like the Netherlands and Denmark and England, these countries were much more pro-science. There was no strong religious authority, and these societies were more accepting of science and scientists. Science and society, 4 consequences. Number 1 consequence, it created new social groups. You had an international scientific community now, and they published lots of journals, and they formed lots of associations. You had people who were making a living off of their scientific discoveries. Science was becoming competitive. Number 2, governments started getting in on the act. There was a new state support for scientific efforts. The inverse was also true. Scientific efforts became more and more directed to supporting the state. You had national, state-sponsored academies of science. Number 3, the emergence of skilled craftsmen and artisans. Think of Igor working for Dr. Frankenstein. These people were also taking an interest in science, and they're the ones making the necessary instruments, and they're conducting precise experiments as they work side by side with the actual scientists. There were new barriers to women in science. That was number 4. And this differed from the Renaissance. In the Renaissance, centers of learning recognized talented noblewomen. But in the Enlightenment, universities and academies gave out credentials to certain accomplished individuals, but they also refused entry to women. There were notable exceptions. Women found many alternative ways to participate in science.